Hello guys, welcome back to the Math Club. The video I am doing today is just a follow-up of the last video which I posted on all my social media pages, on TikTok, on YouTube, on Instagram, and on Facebook, where I showed how we could obtain the eigenvalues and eigenvector when given a matrix in 2 dimensions. So this video now is just a follow-up to complete the last part of the question, which has to do with finding the PDP inverse matrix and also to use the knowledge of diagonalization to obtain matrix powers. Okay, so we are given the matrix n equal to this, and we already, like I said, we already obtained in the last video I already obtained lambda 1 as -1, lambda 2 as 5, the first eigenvector as 1, 2, and the second eigenvector as 1, -1. I already obtained all that in the last video. So let's see how to handle problems that have to do with things like this. So we know that the matrix M is equal to PDP inverse. So which means we are going to find P. How do we obtain P? Our P is for us to actually place our eigenvectors side by side in 2-dimensional form, in 2 by 2 matrix form. So take note, if I'm beginning with eigenvector 1, which is 1, 2, followed by eigenvector 2, which is 1, -1. And mind you, my identity matrix for 2 by 2 matrix is 1, 0, 0, 1. Then my diagonal matrix is going to be for us just to place the eigenvalues. So eigenvalues are supposed to replace this major diagonal. So since I started here with eigenvector 1, I will start with eigenvalue 1. Because if you look at this value, this is eigenvector 1, eigenvector 2. Therefore, my eigenvalue -1 should occupy this position. Then this other position is 0. Then this position will be occupied by eigenvalue 2, which is 5. So in essence, according to my P matrix, eigenvector 1 begins before eigenvector 2. Therefore, eigenvalue 1 should be written before eigenvalue 2. If I wrote 1, -1 and 1, 2 here as my back for my matrix P, therefore my D will be 5, -1. So in essence, the eigenvector that takes the first position, the first column here, its eigenvalue must begin here. The eigenvector that contains the second column, that eigenvector its eigenvalue must also take the second position here along this diagonal. So it is still correct. The answer will still be correct. So that is it. Well, how do I find my inverse matrix? Now, P inverse is 1 all over the determinant of P times the adjugate or the adjoint of the matrix P. So what is the determinant of the matrix P? Determinant of matrix P, which is still the absolute value of P, it is given by major diagonal, multiply the major diagonal, which is 1 times -1 minus 1 multiplied by -1 minus, you multiply the minor diagonal also, 1 multiplied by 2. So that will give us this -1 minus 2. That gives us -3. So actually the determinant of the matrix P, this is our matrix, is -3. So what is the adjoint? The adjoint of P, adjoint of P simply means we interchange the position of the entries along the major diagonal. So here will be -1, then here will be 1. Then for the entries along the minor diagonal, we change only their signs. So since this is +1, it becomes -1. This one is +2, it becomes -2. So that is the adjoint of P. It therefore means P inverse will actually be from this formula, 1 over the determinant, 1 over negative 3 multiplied by the adjoint, which is negative 1, negative 1, negative 2, 1. So therefore, my matrix M will be equal to PDP inverse. Our matrix P is 1, 1. This is our matrix P here, 1, 1, 2, negative 1. The matrix D, this is our matrix D here, which is negative 1, 0, 0, 5, multiplied by our matrix P inverse, which is negative 1/3 into, so I need space, negative 1/3 into negative 1, negative 1, negative 2, 1. So we can still write that as M equal to, this negative 1/3 can go in front, so we have negative 1/3 in front. Multiply these two matrices. So this is P and this is D. So this is P and this is D. Row multiply with column. 1 multiplied by negative 1 is negative 1. 1 multiplied by 0 is 0. So this will be negative 1. I'm still using this row multiply with this column. 1 multiplied by 0 is 0 plus 1 multiplied by 5 is 5. I use this row now multiply with this column. 2 multiplied by negative 1 is negative 2 plus negative 1 multiplied by 0. So this one will be negative 2. I still use this row again, multiply with this column. 2 multiplied by 0 is 0. Negative 1 multiplied by 5 is negative 5. All that multiplied by negative 1, negative 1, negative 2, 1. So our matrix M will actually be this negative. I can use it here to multiply everything here. So I have 1/3 into negative 1, 5, negative 2, negative 5. Bear in mind that this matrix is your PD. So the negative here multiplies everything here. This one becomes 1, this one becomes 1, this one becomes 2, this one becomes negative 1. So I've just taken this negative sign inside this other matrix. So that is our PDP inverse. So it means actually this is our PD, this is our P inverse. Now, what you have to understand about this, what is happening here is that if you multiply out this matrix and the result that you have multiplied by 1/3 is going to give you this matrix if you are correct, the matrix M if you are correct. So how do we obtain M to the power 5? So we know that M to the power N is equal to PD to the power N times P inverse. And we have just seen that P inverse is the same as this times this. So M to the power 5 will be the same as our matrix P, which we know as 1, 1, 2, negative 1. In fact, we have already seen that P inverse is this and this. So we have our 1/3. Our matrix P is 1, 1, 2, negative 1. Our matrix D is 1, 0. Our matrix D is, is negative 1, 0, 0, 5. All that raised to the power 5. Since N now is 5, so D will be raised to the power 5. Raised to the power 5. Then all that multiplied by 1, 1, 2, negative 1. So M raised to the power 5 will be equal to 1 all over 3 into 1, 1, 2, negative 1. Negative 1 raised to the power 5 is negative 1. 0 raised to the power 5 is 0. 0 raised to the power 5 is, okay, because of space, I'm going to write it as 1/3. This situation as 1/3 into 1, 1, 2, negative 1. Negative 1 raised to the power 5 is negative 1. 0 raised to the power 5 is 0. 0 raised to the power 5 is 0. 5 raised to the power 5 is 3,125 multiplied by 1, 1, 2, negative 1. So it means our matrix M to the power 5 is actually equal to multiplying this matrix out. So you can begin by taking this matrix, multiplying by this. The result that you have, you use it to multiply by this. the result that you have, you multiply everything by 1/3, all the entries by 1/3. So that is how you obtain your matrix m raised to the power 5. So that is how, in essence, let me even, so because of space here, if you look at, you can complete this multiplication out in the comments in your private time, and post your results on my time, on the time comment timeline, so that we can verify what actually is your final result. But in essence, just take this matrix, multiply by this matrix, the result that you have will be a 2 by 2 matrix. Use that result, multiply by this, will also be a 2 by 2 matrix. Use the final result, multiply by 1/3. So 1/3 will multiply all the entries. That is actually your m raised to the power 5. So follow me on Facebook, on Twitter, on TikTok, on Instagram for very interesting content in mathematics in the days ahead.